With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, a uniform bar with mass m lies symmetrically across two rapidly rotating fixed rollers A and B with the distance L between the bar and center of mass each roller. The roller whose distance of rotation are as shown against the bar of coefficient of friction mu. Suppose that the bar is displaced horizontally by a displacement x, then release, you have to find out the time period. So when you displace it by a distance x like this, right, then what will happen? The normal reaction position will change. Right now it is symmetrically placed. So net torque, net force, all the system is in equilibrium. So all net force and net torque will be 0. But as soon as you will displace it, the center of mass will get displaced as well by a distance x. So if you see, let's say here the normal reaction will be N1, here the normal reaction will be N2. So it is this. Right. So when it will be displaced about the center, if you see the torque, you can get this distance will be L plus x. This will be L minus x. So you will get a net torque, right? So if you see, we will write down the N1 plus N2, it is equals to mg. And if you see here, the net torque you will write down, so it is not rotating about this center of mass, so net torque will be also 0. So net torque, if I write down, it is L plus x minus x. It is force times of perpendicular distance. So if I write down N1 by N2, it is this. Right. So if you see here, this is L minus x, this is L plus x. You can just break it into two component, mg in this ratio, and you will get the normal reactions, right? So if you see, the N1 will be equals to mg minus x by 2L, N2 will be equals to mg this, right? So in the same way, you can write down the limiting friction. It will be this, and on the second it will be this. So friction force will be acting here in opposite direction, right? If you see, it is rotating in this direction, so here the friction force will be in this direction. It is rotating in this, here the friction force will be this. So let me write down, this is F1 and this is F2, so it will be F1 minus F2. This will be the net force. So it is mu N1 minus N2. So if you see, N1 minus N2, so this minus this you have to do. So if you see, it will be, I will take mg by 2L common, so it is L by x. It will be 2x, so it will be L minus. So this will be the net force, increase in force, right? So proportionality constant, you can write down, it is mu mg by this. Now what we want here, the time period. So I will write down the time period is simply 2 pi under root m by proportionality constant. You can just put the value, right? So as you put the value, the m will get cancelled out, and so let me write down this as c, right? This as L. So it will be L upon mu g, and this will be the answer. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.